So to write any equation, we have y equals plus or minus the vertical stretch times one of our functions. So we've got 6 functions. Looking at this, it's obviously not a sine, cosine, secant, or cosecant. They're either going to be tangents or cotangents. But there are 6 choices. I'm just going to write fun for function. Not fun because this math is so much fun, because to be honest, this is tricky. So you have a times your function, then you have parentheses, then you have how you're compressing the period has to be factored out from your variable x or theta, subtract c, which is your horizontal shift, close both sets of parentheses, then plus d. Okay, so we've got to come out with, just looking at what patterns we can see, what start we've been given, general information from the graph, we have to work out if it's positive or negative and what type of function. Then we have to come up with numbers for A, B, C, and D. Okay? Now, the easiest thing to do is to put some extra marks on your graph. Label it up a bit. This one's already got the midline labeled, but you can see points here and here. So that's obviously a high line. Dot that on your graph, label it high, and we've got a low line. This is at -2. You can read that on the scale, it's there. It might be very small on yours. Okay, high, middle, and low. Mark up your graph a bit. Now that's going to really help us So those markings will help us identify what we need to do. The first thing we'll look at is the vertical shift. The vertical shift is where your midline is. Now this is actually on, this is the x-axis. So it hasn't been shifted vertically at all. Our value of d on this one is just 0. The next thing we look at is the vertical stretch, and that's the distance from the midline to the high, or from the midline to the low. You look at, they should be the same. On our graph, this point here is labeled 2. So from 0 to 2, our value of A is 2. Those are really, really easy to pull out from the graph. Then B. Ooh, B's tricky. B is something you can't just read it from the graph. You have to get information from the graph and then do a calculation. B is the hardest. That's your horizontal compression. It's what will change your period. It is not the period itself. It's what you have to do to change the period. And then C is your horizontal shift. So that's going to depend on where you've been told your wave has to start. So for some reason, when I wrote this, I put this one, called this one number 2 and that one number 1, which was ridiculous, really. We'll do number 2 first, just because going right to left, that comes first. So number 2 has been marked with a star. Well, normally you would circle the point. Now notice what we're circling here. It's not actually a point on one of the curves, it's a point on an asymptote. So looking at that start, it's on the y-axis, so there's no horizontal shift. Your value of C in here would be 0, but it's telling us it's more than that. It's telling us the pattern starts on an asymptote. Let's look at the pattern going forwards from that point. It's going asymptote, then there's this point here which is on the low line, there's this point here that's on the midline, there's this point here that's on the high line, and then over here, there would be an asymptote. So from that circle point, the pattern goes A, asymptote, low, middle, high, asymptote. And that is the information that's going to tell me which function I'm working with. Okay, I'm going to match that to a function. So I'm not going to do that work yet. Let's just look at the equivalent information we'll do for this start. Okay, it's been marked with a star, but the point that's been circled there is on the midline. So the pattern from this point going forwards goes middle, then it's a high, then it'd be an asymptote, then if it carried on, the next point would be a low, then a middle. And that pattern is going to tell me if this is a tangent or a cotangent. Okay, we'll have a look at that in a minute, but it's also going to give me this value of C. That's the shift. How far has it shifted from the y-axis? Here was the y-axis. That start point has been shifted. That's pi by 2. This is pi by 6. Pi by 6 to the right. So my C, so pi by shift pi by 6 right. My C is positive pi by 6, but I know that what's actually going to be written inside my equation will be x subtract that. Remember, you always go the opposite way. The equation kind of lies to you for your horizontal shifts. So what have we worked out so far? We've worked out A and D for both equations. It was the same for both of them. We've worked out C, and we've avoided B like the plague because B is difficult. We know that here was our value of D. Let's put this in this information. D is there. A was 2. And let's work out B. To work out B, it's going to be linked with a period. You're going to read the period from the graph, and then you're going to calculate B. Let's do this. I'm going to do this on a nice, clean chart. Okay? That's the same graph, but I want to get rid of all the other stuff so you can see what we're doing. How to find the period. Choose any 2 points. You could choose from this one to this one. That's one step. But the math there is horrible. You're going from pi by 6 to pi by 4. Yuck. Ugh, don't do that. Why not start on your y-axis where x equals 0? Now the math is going to be easy. Take one step, and it would take you to this low point. And that is the distance you've just gone. One step had a length from 0 to pi by 12. One step had a length of pi by 12. A period is made out of 4 steps. So it's going to be 4 times pi by 12, which reduces down to pi by 3. And now we have to calculate B. It is not pi by 3. B is the period and B are not the same thing. Remember when we were actually, for a sine and a cosine, when we were graphing them, we said that the period was 2 pi compressed by B. But these aren't sine and cosines, these are tangent and cotangents. On a tangent and cotangent, your period is being compressed by B from what the parent function's period was, which was pi. We need to use this information for tangent and cotangent. This is only for sine and cosine, and we haven't got sine and cosine graph. So I know that the period that equals pi over B. Now solve that. Now this is an easy one, yeah? Sometimes you get this and you cross multiply and divide or whatever. But on this one, can you see what we've got here? If the numerators are the same, then guess what? The denominators are the same as well. B must be 3. Sometimes you'd have to do more of a calculation than that, okay? But B does not equal the period that you read from the graph. You have to find the period and then use it to calculate B, okay? You find the period, use it to calculate. Oh, I can't spell today. And this goes in the equation. So going back to our actual problem we were working on. So we knew that our period was pi over 3, and in this case that equaled pi over b, so it told us that b was 3. So we know all the information now, except for we haven't used these patterns. I still don't know if I'm writing positive or negative sine or cotangent for them, cotangent or tangent for them, right? Let's clear off some of the information of this graph to make it easier to look at. This is the actual graph. It's these curves. It's increasing. Now, an increasing graph, the one that increases is a positive tangent. A decreasing graph is a negative cotangent, okay? It's a positive tangent, but tangents start on the middle value. They go middle, high, asymptote, low, middle. So that's here. Okay, that's this one. This is exactly this. Equation number 1 is going to be a positive tangent. This one starts on an asymptote. So it goes asymptote, low, middle, high. The fact it starts on an asymptote tells me it is a cotangent, but cotangents, normally a positive cotangent, the pattern for cotangent is asymptote, high, middle, low, asymptote. I haven't got that. I've got asymptote, low, middle, high, asymptote. So what we've been given is actually a reflected cotangent. This is a negative cotangent. Okay, I'm going to erase this extra work here, and we're just going to write the equations. Right, so the equations we've got to write 2 of them. For the one that starts at start number 2, the information we've got is it is a negative cotangent. I'm going to write equation y equals negative cotangent. Now remember the value of a has to go in here, and our value of a was 2. Then I do parentheses, and I do the value of b, so b goes in here. Then I do parentheses, then I do x minus c. On this one, c was 0. Close both parentheses, then I add on the value of d. Oh, that was adding 0. Oh my goodness. We don't have to do adding and subtracting 0. That stuff I don't need to write. So in actual fact, I could have just written there 3x. Done. Okay. This was A, this was B, and for number 2, my C was 0, and for both of them, D is going to be 0. So that's the equation I want for start number 2. Let's look at the equation for start number 1. It's y equals, I said it was a positive tangent. I don't have to write plus. I do have to write tangent, and in front of it, I have to put that A. So it's 2 tan. Then I've got my value of B, which was 3. You go A, B, C, D, yeah? 3, parentheses, x minus c. Oh, and this wasn't 0, so I do have to keep all these parentheses now. X minus that value. We're going to write, so we subtract. And then you would add on D, yeah? This was your value of B, this was your value of C, and then you put on the end the value of D. Okay, so that's that one. Okay, I'll give you a second to make sure you've got all that written down. We'll take a screenshot if you need the screenshot. Okay, so we're going to, what I want you to work on now
is I want you to finish off these practice problems. There's 3 I really want you to do, and I would strongly suggest doing the next 2 as well, because they really make you think. But if you're not in the mood to think and you think you can get away without doing that practice, you skip it. Okay, but at least the first 3, I've done the first one for you, must be submitted before the end of class. Here is the second one. Oh, here's the second one. This is your second one. So there's basically only 4 patterns you need to remember, and you can build all of the rest of them from there. So you need to know how the pattern for a positive sine, a positive cosine, a positive tangent, and a positive cotangent. Okay? Those you need to memorize, so it's worth writing them down. And then the others you should be able to just make up as you go along based on those. The pattern for a sine is middle, high, middle, low, middle. The pattern for positive cosine is high, middle, low, middle, high. Now you can use those 2 to do a negative sine, negative cosine, positive and negative cosecant, positive and negative secant. How you do it is, if you want a negative sine, you just turn all the highs to lows and the lows to highs. The middles would stay the same. If you want to do the reciprocal of sine, sine begins with S, its reciprocal begins with C, cosecant. To get the cosecant, you turn all the mids. Your mids become asymptotes instead. So your pattern for a positive cosecant is asymptote, the highs and lows stay the same. Asymptote high, which will have a smile on it. Asymptote low, the low will have a frown on it. Asymptote. That's a positive cosecant. And a negative cosecant turns all your highs to low and your lows to highs. But you don't need to memorize any of the stuff that's in pink. You just need the stuff that's in green. And the same for a negative cosine, you would go low, middle, high, middle, low. And for a secant, positive, you just turn all these mids into asymptotes. So go high, asymptote, low, asymptote, high. And for a negative secant, turn the highs to lows and the lows to highs. So that's a heck of a lot to write down, but all you need to remember is the 2 green ones. And you're better off not having the other ones written out and just trying to work them out as you go along. Now I have a little bit of a problem myself on tangent and cotangent. I remember that they both have the same high and low, but on one of them, where it has an asymptote, the other one has a mid, and where the other one has a mid, the other one has an asymptote. That's the effect that you have, mid turning to asymptotes when you do reciprocals. So all I remember is that cotangent, I picture that as 0. When x is 0, you have an asymptote. So that tells me it goes from asymptote, starts with an asymptote, which tells me tangent starts with a midline. Then I remember that tangent is increasing and cotangent is decreasing. The decreasing is kind of easier to do, starting from an asymptote. Decreasing, start with your high, high, and decrease, high, middle, low. And then increasing from a midpoint, I'm going to go high, and then that would be the asymptote, so that would be low, that would be middle. Okay, these you need to know. You need to know this one, and these 2. And while you're at it, you need to know the length of their period, from asymptote to asymptote on a cotangent, or from mid to mid on a tangent, or high to high on a cosine, or mid past one mid into the next mid on a sine. Okay, your periods. For these functions, the parent function period is 2 pi. So when you have a compression, when it's compressed, your new period will be 2 pi compressed by that b in the equation. For tangent and cotangent, the period that you start with is pi. So when you're working out a new period, it is just 1 pi divided by b. Okay? Now, how to read the period from a graph? The way I showed you just now is I said, just look for one step. And the easiest place to start is on the y-axis. Y-axis, go to the next sort of step in your pattern and read that, how far you went. Look for one step, and then the period is 4 steps. So you just multiply that length by 4. There is another way that if you've got enough graph graphed, the period is the length of one cycle, length of one full cycle. That's its definition. Now, what you can do is look for the y-axis. And this makes your math easy because it means that you're at x is 0. Look where you are in the pattern. Now, I've deliberately drawn something really weird here. Look, that's your midpoint, that's your high point, that's your low. We're not on one of the special points, but we're at a weird point in the cycle. Is this a full cycle there? No, 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 no. You've done a full wave when you're back, and your next wave would start there, yeah? So all you have to do, you know that this is one complete wave. Come down to your x-axis and see what number is written there. Just read the label. Read the label on the graph, and hopefully it's been labeled for you, or you can work it out from the scale you have been given. That is one period. It's gone from weird point to weird point. They weren't even highs, middles, or lows, but you have done one complete wave. And then you can just use the markings on the axis. That's a hint that makes finding the period easy sometimes, but you have to have a whole wave, or the whole way through one of these patterns, like asymptote to asymptote on a cotangent. At least that amount has, or if the cotangent starts on the high, if that was the y-axis there, if the y-axis was there, I don't mean start, I mean if the y-axis hit the high, you'd go look at the distance to the next high, and that would be one period. Okay. Because that is quite tricky on, is it this way? Yeah. Look how we can use that on this wave. You're at the high on that wave. Look to the next time you're on the high. That is one complete wave. That's your period. So, and that equals pi over b. So what does b equal? B must be 1 on that one. I've done some work for you. I wasn't supposed to do that.